Hello everyone, I'm Deepthi M, pursuing Electronics Communication Engineering in Bengaluru Institute of Technology. My seminar topic for data structure using C is the Josephus Problem. Here's a quick overview of what you will cover today. Introduction to the Josephus Problem, the scenario and the elimination method, key steps in the process, input and output requirements, a detailed example, why we use a circular linked list, the algorithm explained step by step, a C implementation of the algorithm, key helper functions and the outputs, and finally a conclusion. This flow will help us understand not just what the Josephus problem is, but also how it is implemented programmatically. Okay, let's dive into the next slide. What is the Josephus problem? The Josephus problem is a classical mathematical puzzle. It originates from a story involving a Jewish historian named Flavius Josephus. During a war, he and 40 soldiers were trapped in a cave. Rather than surrender, they decide to commit suicide in a circle by killing every nth person. So Josephus, not wanting to die, cleverly chose a position where he would be the last survivor. So this puzzle models a situation where people in a circle are eliminated one by one at every nth position until only one person is left. Next, let us introduce Josephus problem, how the step-by-step process is going to take place. Let's bring a story to life. The first is scenario. A group of soldiers are surrounded by enemies. They know that only one person can survive and escape to get help. So with limited time and one horse, they decided to form a circle and use a counting method to choose who survives. Second is the escape plan. To make the decision fair, they agree that every end soldier will be eliminated in a loop until only one remains. This way, the survivor can take the oars and go for help. The scenario is what forms the base of the Josephus algorithm. The elimination method is the soldiers are systematically eliminated from the circle, with every end soldier being removed until only one remains and the sole survivor escapes and someone's help. Next, the elimination process is explained in detail. So, how is the elimination done? Let us imagine the soldier standing in a circle. You choose number n and then count clockwise. Every n person is removed from the circle. This process continues, always starting the next count from the person immediately after the one who was just removed. Eventually, one person is left, thus the survivor. This is how the elimination process is going to take place. Next, key steps in the elimination process. To summarize the elimination logic, we choose a starting soldier and a number n, counting clockwise, removing n soldier. After each elimination, counting resumes from the next person, continuing until one person remains. This sounds simple, but to simulate it programmatically, we need a special data structure called circular linked list because it allows endless looping through the group. Let's dive into the next slide. Next is input and output requirements. To solve this problem using code, we need your input, a number n, which tells us how many people to count before eliminating one, a list of names representing soldiers entered in order. The list ends when the user types in. The output is first we print the names of the soldier in the order they are eliminated, then we print the name of the last remaining soldier, the survivor. Those inputs and outputs help simulate the circle and the counting process. Next, let us understand the Josephus problem with an example. Let's consider n is equals to 3 and soldiers are A, B, C, D and E. Here's what happens. Count A, B, C and C is eliminated. Next D, E, A and A is eliminated. Then B, D, A, then E is eliminated. Then B, D, B, B is eliminated. Now only D is left, so D is the survivor. This example helps us to understand how the logic plays out in each round. Next slide is Why use a circular linked list? It is perfect for this. Is it perfect for this problem? First, it is continuous loop. Since we need to keep counting around the circle again and again, a circular list allows smooth traversal without resetting. And second is efficient removal. Deleting a node is simple and doesn't break the structure. Third is natural end condition. When only one node is left, the process naturally stops. In short, a circular linked list let us replicate the circular behavior of the soldiers easily. Next is Josephus Problems algorithm. At first stage, we have to gather the input, read the counting number n, and insert the soldiers into a circular linked list. Second step is elimination of the loop. Counting n minus 1 nodes, eliminating the nth node, repeat until 1 remains. Third step is output. Print the order of the elimination and final survivor's name. So in this slide, I'm going to explain how algorithm works. Here's how the algorithm works step by step. Read the value of n, read name one by one and insert them into the circular linked list. In the while loop, it continues to read until the end step as the while loop condition is not equal to name is not equal to n. And next, in another loop, here we are considering the list. There is more than one node on the list. So the count n minus 1 nodes to find the nth node and prints and removes the nth node. It repeats until one node remains. At last, prints the name of the last remaining soldier. This loop replicates this logic we saw earlier. Each step mimics the counting and elimination. So let's dive into next slide. In this slide, we are going to see Josephus problem in C implementation. This is the main function that solves the Josephus problem. The string is used to stop reading names for the user. If the user type end, we stop inserting names into the list. Next, we have declared a character array name to store each input name, and the max length is a predefined constant representing the maximum length of a name. And next, we have declared an integer I n and for looping and n for the count numbers, step size in elimination. Next is declare a pointer list that will point to the head of the circular linked list, initially set to null, because the list is empty at the start. Next, we have we have prompt the user to enter the integer n, and n is a step. As we know, n is a step count. Every nth person will be eliminated as the nth person will be eliminated. Next, we have prompted the user to enter the name. Reads the first name into the name variable. Next, we have written a while loop in which the condition is it keeps inserting names into the circular linked list until the user types end. And we have used EQSTR function to compare current name with the end name. Next is we are printing the header before elimination starts. Let's continue with the next slide. Uh, in this, we have used a loop in which it loops until only one node in the list is left. Your list is equals to list next means there's only one node that points to itself. Next, we have used the for loop. It moves n minus 1 steps ahead in the circular list to reach the node before the one that should be deleted. Next, deletes the node after the current list node using a del after function. The deleted soldier's name is printed later as we have used the name here. Next, printf the soldiers who have escaped. Here it points to the list info. After the loop ends, one soldier is left, so it prints the name as the survivor, frees the last node, uh, and last node's memory using the free node f. This code is efficient and uses a basic linked list operation to model the entire problem. So next, let's go into the next slide. So let's go over some important functions which we use in the program. That is insert, which adds a soldier's name to the circular list, and delafter function, which deletes the nodes right after a given node, and the free node frees up a memory of the deleted node, and eqstr function manually compares two strings since we don't use direct string assignment. Each of this function keeps the list updated and makes the main logic cleaner. And we have used a manual string handling method, and the order of elimination is the output and the name of the surviving soldier is the output. Uh, at last, we can conclude that to wrap up, the Joseph problem is a clever example of combining historical logic with the computer science techniques. It's a perfect way to understand circular data structure, efficient node deletion, loop-based elimination. Understanding this gives us deeper appreciation of how we can use data structures to solve real-world like problems. So this was about it, the Josephus problem. Thank you, everyone.